I'm a Sybil and I'm going to do both attacks, DDoS and Sybil attacks, basically I'm going to DDoS the miners. The best I can do is basically stall the blockchain and prevent any view changes from happening and be able to take over the network. So there's one corner case where you have 70% of the Sybils, 70% of the miners as Sybils as your own, and then you conduct a DDoS to prevent any view changes so that you can still maintain the status quo. But that's a very rare event. That is basically that's the extent of the Byzantine tolerance, right?
Yeah, the reality is any existing Byzantine tolerant protocol, they all assume 1/3 is maximum that they can support and so on, right? But at the same time, we also, maybe we can talk a little bit about our active set and how that keeps changing periodically, right?
So we have
the view change concept.
Maybe you can erase some of this stuff too, because there's not enough room now.
No, I think that's okay. Because so VRF is the mechanism with which we also do the view change. Okay. So maybe we can talk a little bit about how the VRF itself kind of works, right? So you have the notion of something called DKG, distributed key generation. And there is another concept which is called threshold signature. Okay. Right. So the idea is that you need at any given time T of n signatures to reconstruct a value. Right. That's the threshold signature, and to go through this threshold signature process, you need to initially create the keys. And the key generation mechanism could be centralized mechanism or a decentralized mechanism. So we have elected to go with the DKG, which is the distributed key generation. And once you have gone through the DKG process, then each miner will have a small piece of the key, of this distributed key. And this key share is different from the keys that they use for the regular operation in terms of the signing of the transactions and validating of the transactions, all of that, which they use the regular any wallet key, which is different from this the VRF specific thing. Now the VRF one, which is kind of a threshold signature kind of a thing, you go through the DKG process and you create this T of n. What this means is, at any given time, to create the what we call as the round random seed, which is basically you take the previous round random seed, you go through this threshold signature process on that, and as soon as you have T of them available, any party which has T of them available, they can combine those and recover this the round random seed for the current round. Okay, so that's how this works for each round. Now, what we decided to do was use the same process to also establish in terms of how you kind of go through the view change process. Now, in the view change process, basically at any given time you have, so the blockchain is progressing like this, and let's say this is a candidate time when the view change is about to happen. So somewhere a little bit before, a DKG process is kicked off, right? And so you have some miner set M. Okay, up until here. So, and then what happens is a few people may want to drop off, okay, and some may want to join, right? So essentially, by some point here, you kind of lock it down.
Maybe you should raise that all up so that you get some room.
So you kind of lock down the set of people with which you are going to operate, right? And then you're going to go through the DKG process. And even the DKG process is going to be a little bit tricky, because what if somebody wants to join and at the time of the DKG was about to happen, maybe they are not online or they're trying to do a Byzantine case and so on. So that's where this protocol tries to make sure that it will take eventually a subset, like going through multiple rounds and trying to establish a subset of the miners that are eventually going to be able to carry through the same DKG once the view change happens. So once you identify this set, then what is going to happen is we are going to use that, and similar to the round random seed, we are going to compute a value with which we are going to establish some kind of a ranking for all the miners that are expected to continue forward. Now imagine we are going to operate an active miner set of only 100, right? And let's say you have 120 miners that are signed up and ready to go. We use this ranking mechanism and pick the first 100, right? So these 100 miners, and these are the miners that will carry forward from here. Okay, and here is where the view change happens, and we every time there is a view change, we call that as a magic block, where that transaction is kind of registered, and you see all the miners that are going to be active from here onwards. That is registered as a transaction here, so anybody can verify later on. And it's like a relay race, right? Like the initial set of people, they come up all the way here, and then they are handing over the blockchain to a new set of people.